Hello, good day viewers. Welcome to another mathematics lesson. This is your presenter, Mr. Mlenga. So right here with me, I've got a question that is coming from mathematics paper 2. And this is a question coming from the topic called sequence and series, specifically geometric progression. The question reads, find the nth term of a geometric progression. So this is the sequence that we have for this geometric progression, which is 4, 12, 36 and 108. Okay, so the question wants us to find the nth term. So in order for us to find the nth term of a geometric progression, we need to come up with the formula. So the formula is going to be nth term is equal to ar to the power n minus 1. Okay, so here we need to find the value of a and the value of r, which is the common ratio. So to find these values, we are going to write our sequence. So we have 4, 12, 36, 108. So this is our sequence. So 4 is our term 1, okay? Then 12 is our term 2, 36 our term 3, 108 our term 4. So a is equal to 4, which is the first term. Then r, the common ratio, is found by dividing term 2 divided by term 1, okay? Or you can say term 3 divided by term 2. You are going to get the same value. So in this case, when we divide, you find that term 2 is a 12, which is right here, okay? And term 1 is a what? It's a 4. So when we divide 12 divided by 4, we're just going to say 4 here, 1, 4 into 12, it's a 3. 1 into 3, it's a 3. So the value of the common ratio is a 3. So since this is the nth term, where we have n, we are going to maintain. It's not going to change. So let us now proceed. You say nth term is equal to, where there is a, we are going to put a 4, which is the first term, times r, we have said, is a 3 to the power n minus 1. So this is our answer. Don't make a mistake of multiplying 4 times 3, okay? Because this 3, the base 3, is raised to the power of n minus 1. So it's affecting this base 3. So you can't multiply 4 times 3, you get a 12. No, you leave your answer at this stage. So I have answered question 1. Let us now move on to question 2. This is our question 2 right here. The question reads, if x minus 2, x and x plus 3 are the first 3 terms of a geometric progression, find a, the value of x. So they want us to find the value of x. So to find the value of x, we need to take note of the terms that we have. In this case, we have been given the terms x minus 2, x, x plus 3. These are the first 3 terms that we have. Okay, so what we are going to do is, we are going to name our terms. This is term 1, and this x is a term 2. This x plus 3 is a term 3. So to find the value of x, we know that when you are finding the common ratio under the geometric progression, we normally divide, okay? We say term 2 divided by term 1, which will be also equal to term 3 divided by term 2. So we are going to use the same idea, where we say term 2 divided by term 1 is also equal to term 3 divided by term 2. So this idea is what we are going to use. So from here, let us just substitute. So when you look at what we have, our term 2 is x. So I'll substitute here x over our term 1 is x minus 2 right here, over x minus 2, sorry, equal to. So our term 3 is x plus 3, x plus 3, over our term 2 is x, like this. So from this stage, we are going to cross multiply. So when we cross multiply x times x, we are going to have x squared equal to, so this is x minus 2 times x plus 3. So I'll write it here, x minus 2 times x plus 3. So from this side we can write x squared is equal to, so this x times this x is going to give us x squared, x times positive 3 to give us positive 3x, then negative 2 times x to give us negative 2x, then negative 2 times positive 3 to give us negative 6. So from here we can try to reduce these terms here. So we're going to have x squared is equal to x squared, then positive 3x minus 2x. Okay, this will give us a positive x minus 6. So from this stage now, we can try to correct the right terms. So we can see that when we take this x squared where we have this other x squared, they are going to cancel. It will be a minus. So this and this will cancel. So therefore, we are going to remain with this x will come here. So it will be a negative x equal to negative 6. So we have just cancelled x squared and x squared, because when you cross this like term, it will be a minus. Okay, and this positive x will also become a minus x. So you need to find the value of x, not negative x. Okay, so we divide both sides of the equation by negative 1 even here. So our final answer now, we are going to have our final answer. We just cancel this and this. Therefore, x is equal to negative 1. Negative 1 into 6, it's 6. So the value of x is equal to what? A 6. So we have answered our question 1a. Let us now move on to our question 1b, which is right here. So this is our question 1b. Now, before we answer this question, remember this is our sequence. We add this sequence, x minus 2, comma x, comma x plus a 3. This is our sequence. Now we have found that the value of x is equal to a 6. So we need just to substitute here in our sequence. So to substitute in our sequence, we are going to have 6 minus 2, comma 6, comma 6 plus 3. Okay, so 6 minus 2, this would be a 4, comma 6, comma 9. Okay, so this will be our new sequence, 4, 6, and 9. Now we can answer the question. So the question is, find the common ratio. So they want us to find the common ratio of this sequence. Okay, so how do we find the common ratio? We said common ratio, which is R, is found by, we said term 2, okay, divided by term 1. So our term 2 divided by our term 1. So in this case, we are just going to consider this new sequence. So this is term 1, this is term 2, this is term 3. So common ratio is equal to, our term 2 is a 6 divided by our term 1, which is a 4. Okay, so when you divide here, 6 divided by 4, what are we going to get? We just say R equal to, so we can say highest common factor of 6 and 4, it's a 2. Okay, where you say 2 here, it's 2. 2 into 6, it's a 3. So we have 3 over a 2. This is our common ratio. Okay, so we've come to the end of our lesson. Thank you so much, everybody, for having time to view this content. Please don't forget to subscribe to my YouTube channel so that you can view more of such content. Thank you once again. This has been your presenter, Mr. Mlenga. Bye-bye.